us to determine the velocity vector and the position vector. The way I did that was, at first I realized that the initial velocity is in vector components. So it made it easy to identify x, y, and z. And I first distributed that and I wrote it down, and then I used the other information the problem states, which is the acceleration of the rocket is 2.5 meters over second squared. And it says that the crosswind blowing is to the north, and the y-axis is pointing to the north. Therefore, it's only affecting the y. And that's why I added 2.5 meters over second squared to this. Then I also subtracted gravity, which is 9.8, to z, because gravity is coming vertically and it's pushing down. So that means that I have to subtract it. Z is also vertically and it's opposite of g. And that leads me to my answer, 200, 350 plus 2.5 times time, 550 minus 9.8 times time. The position vector formula is initial position plus initial velocity times time plus 1/2 of acceleration times time squared, or t squared, which is time. And we first have right here, as we follow the equation, we have 0, 0, 20 for the position vector, for the initial position vector. And then we have the initial velocity, which is something that we had previously stated. And it's 200, 350, 550, plus 1/2, still following this equation. And the acceleration is 0, 2.5, and 9.8. Negative 9.8, and then t squared. And then as we simplify this equation, we start to distributing everything. As we can see, this is still in vector components, so it's x, y, z in each of these. So as we simplified it, so we got 200t, and then we have 350t plus 1.25t squared, 550t minus 4.9t squared plus 20. And the reason why we have it like this, 1.25 instead of 2.5, is because we integrated. And integrating requires us to divide based on what we got as our exponent. And since we have 2, therefore we had to divide what we had by 2. Then for B, we chose to answer A, because as we can see here, this would be the correct answer, because it's showing us that it's showing us how x and y and z are being affected, but these other two options are not being affected. Rather, they're showing just for example, x and y, or I'm sorry, z and y, and then z and x. And that's not true. It's actually all 3 components that we have in this problem that are that we have identified to create this graph. And then C asks us to determine the flight and range of the object. So that leads me to the quadratic equation formula. We have A, which is negative 4.9, B 550, and C equals to 20. So this is the quadratic formula, and then we start plugging things in now that we have identified our variables, which is right here we have negative 550 plus or minus squared 550 squared minus 4 times negative 4.9, 20. And it's, again, once, like I said before, we have negative 4.9 because of the integration that we had to do in problem B and problem A. So as we start to simplify, we first, we first square it, and we find what's inside of the square root. We multiply what needs to be multiplied, and we get 302,500 plus 392, which leads us to an answer of 550.356. And then after that, we do both plus and minus, which is negative 550 plus 550, 550.356 divided by negative 9.8, which is gravity. And we both divided it by gravity, and then for x and y we got, for t we got negative 0.0363 and 112.281, and that actually stands for the time. So now we have found time, which is 112.28 seconds. And then we go and then there's more to this equation. So now we have to find x and y, which is, so we now have x and y. So we know from what we already had that x is 200. So now since we have time, we are able to find the range. And range would just be plugging in time. So for here we have 200 times 112.281, which gives us 22,456.2. And then for y we have 350 times time plus 1.25 t squared. And then here and then we have this equation for y, because based on, if we go back to number 1, right here our answer was 350 t plus 1.25 t squared, and therefore that's why we are using it to find the range of the rocket. And as we can see, we square time, and then we just add in both variables, or the variables we get, and we get 55,057.13. And then we have to pretty much square both of these answers, and then find the answer, which is 59,460.647 meters. And then for D, we had to find the maximum height. And in order to find the maximum height, we had to do 550 t minus 9.8 t, which is equal, we are equaling it to 0, and then isolating t. And then in order to isolate t, we had to first we added 9.8 to this side, and then to isolate t we had to divide by 9.8. So t equals 550 over 9.8, which gives us 56.122 seconds. And then now that we're finding the maximum height, and that's why I put h max equals, so what I would have to do, which is the maximum height is vertical, so therefore that leads us back to this equation that we initially had, which here is 550 t minus 4.9 t squared plus 20, because this is the equation to find the maximum height vertically. And then after simplifying, we get 15,453.573 meters. Thank you, and this is me just to verify that I'm the one speaking.